Minnesota is getting the most advanced hypersonic wind facility in the US. Learn more about what it means for hypersonic flight, rockets, and more. Today on the Twin Cities Business Show, I'm Charlie Ryback, and today our guest is Northwind CEO, Dr. Artie Mabbett. Welcome to the Twin Cities Business Show. I'm Charlie Ryback, and I'm here today with Dr. Artie Mabbett, CEO of Northwind. Welcome to the show.
Hey, good morning. How are you today?
Excellent.
Good.
Um, so hypersonics.
Yes, sir.
Let's get right into it. Growing up, supersonic was the fastest thing I'd ever heard of,
Uh-huh.
but I understand there is a faster speed. Can you take us a little bit into what hypersonics are?
Yeah, absolutely. It's a great question. So hypersonics is technically it's just a speed regime, right? A lot of people talk about hypersonics being a thing. It's just because that's what they're applying it to, like a
Hmm.
hypersonic, space plane or missile or what have you. But hypersonics is basically 5 times the speed of sound. So that's basically a mile a second. So incredibly fast if you can kind of wrap your head around that. One of the quick data points I did when I was out here last giving a talk is, if I recall, it was basically I could be at the beach in Honolulu in 45 minutes from Minneapolis, which would
Wow,
be pretty awesome,
that
especially in the winter.
that would have been really helpful in January.
Yep, I agree.
So you guys are building the most advanced hypersonic wind facility in the US
Hmm.
in Rosemount.
That's right.
Tell us a little bit about just the basics of the facility that you guys are building and kind of what you're up to.
Sure, sure. So the whole concept is essentially to bring state of the art technology to develop and build out wind tunnel facilities so that we can do advanced aerodynamic and aero propulsion. So engine systems at these kind of speeds. The country has a handful of test capabilities across the nation, but most of those were built in the 50s, 60s, 70s. Great tunnels, but very low throughput, low capacity, and again built with older technology. What we're able to do in Rosemont is really bring new technologies, AI, autonomy, 3D printing, automation, things of that nature to really streamline and accelerate our ability to learn on really accelerated timelines more affordably. And by utilizing those technologies, we're actually able to help customers, everybody from new entrants in the defense ecosystem to the prime integrators to government, really essentially learn faster. So we're building out about 60 acres down in Rosemont. It'll have 3 tunnels on it. One tunnel is the trisonic tunnel. The trisonic tunnel basically goes from subsonic to supersonic to hypersonic,
Okay.
and that allows you basically to sweep through the various speed regimes that would be very applicable to basically think about anything that starts from zero speed that gets to hypersonic. So a space plane, a high speed engine that starts again at ground level and accelerates through that. So it gives you an opportunity to look at that whole dynamic of going from low speed to high speed. The second tunnel is very much focused on the hypersonic regime. So that would be an aerodynamic testing for, really things like, so we're aiming at Mach 6, which is 6 times the speed of sound, Mach 8, 8 times the speed of sound, and Mach 10, 10 times the speed of sound. That would be for external flow. So basically putting an aircraft, in there and seeing how the wind, flows over the vehicle. So you can check aerodynamics, control surfaces, things of that nature. And then the last tunnel, which is the most advanced, will be an aero propulsion tunnel. And what that means is basically we could take high speed engine systems and run them just as if they were flying at hypersonic speeds at altitude. So you can put the entire engine system in there and allow it to simulate the environment as if you were flying it at altitude at Mach 6 or Mach 7.
So if we're going to get hypersonic flight, which can take you, from here to Hawaii in 45 minutes, this is the type of facility where that research would be done and where something like that would potentially come out of.
That's absolutely it. Yeah, it's as you can imagine, these systems are incredibly complex. So to just build and try by trial of error is not quite very affordable. So we really try to simulate as much as we can on the ground these test environments, so that we can really build the confidence as we go out to develop the next phases of those to then ultimately get them to flight test. So it's a way to accelerate the learning. It's a way to drive cost out of the development and build confidence before we actually go build a full system to fly.
Really interesting.
Yeah.
One of the very interesting uh, problems I came across when researching this is, this is really advanced physics stuff that you're doing here.
Hmm.
It feels like the type of thing that in a world of rapidly advancing AI, you could just have computers doing. Why would you need a wind tunnel to do this? And as I was poking around more, it seems like that's really not the case. That this is still something that is not only a necessity, but is something that you sort of pair AI into to get some of the answers we're looking for. Can you dig in a little bit on that and kind of how the field has changed in the last couple of years?
Yeah, no, that's a great question. It's awesome because we haven't spoken about this before, but it is absolutely where we're going. So over the years, really the traditional testing has been to bring a test asset, right, a wind tunnel model, whether it's an airplane or space vehicle, what have you, bring it into the tunnel, and you basically run a test series at various speeds, various they call it angle of attack. Basically, am I at zero, pitched up, pitched down? Because you're trying to build a database of aerodynamic performance.
Mhm.
And historically, you'll go in the tunnel, you'll test, you'll then come out of the tunnel, post process the data, analyze the data, think about, okay, hey, I need to get more data around this certain point. I'll go back into the tunnel, I'll rerun conditions, I'll look for things, there might be anomalies, there might be, weird dynamics that happen. So you might want to focus on a certain speed or something of that. And that process can take you 6 months at times,
Yeah.
right? But you spend a week in the tunnel, then 2 or 3 weeks analyzing it, a week back in the tunnel. And so you can do that over 6 months. The challenge with that, as you can imagine, is there's a lot of people that want to get in the tunnels. So throughput becomes a big challenge. And every time you go in the tunnel, it could be upwards of $1 million a week to go test at one of these facilities. We actually just demonstrated a few months back the ability to train an AI algorithm to identify when it sees those anomalies and uncertainties
Mm.
so that in real time it will do the uncertainty analysis. So in other words, when I used to go find it out, manually, I'd then go back and run the test. We actually now can put the model in the tunnel and let an automation tool basically run through those various scenarios. And when the AI identifies an area it needs to get more data, it will pause and iterate around those data points. So it basically was doing what the manual person would do outside the tunnel and was able to do it real time. So what we
Wow.
actually just did was take a 6 month process and we did it in about 2.5 minutes by using AI to do all of the data processing. So yeah, as you can imagine, the throughput that we're able to do when we can compress those timelines, just cost alone, right? Again, 4 weeks in a tunnel, $4 million. You can do it in a couple days now. So really, really incredible. And that's really what the nation needs. It's that capability that we're bringing to the Rosemount facility, but also what we learn and develop in the tools there can be applied across the nation in our other facilities as well.
Really interesting. So I think you just hit on it. $1 million a week in the
Hmm.
tunnel to operate the tunnel, basically.
That's right.
Where is all the money for this coming from?
So various places. So for the project itself, it's a really unique public-private partnership. So this is somewhat of an experiment. It's been going great, but we're really looking at how we best leverage federal dollars with private investment. Northwind is bringing a significant amount of hardware, in-kind activities. Over the years, we've collected large compressors for other wind tunnels that aren't being used today. So we're going to bring all those capabilities to bear, and then the state funding as well to build out the facility. So this is probably first time in decades the nation's ever done anything like this, and probably the first time we've ever done a public-private partnership when we have federal, state, and private investment going to this to really deliver a capability that the nation needs.
Really interesting. And you guys have kind of been partnering with the University of Minnesota on
Hmm.
this, and as I understand it, the University of Minnesota has pretty advanced research on some of this
They
stuff. Can
do.
you dig into kind of how that happened and how that partnership came to be?
Yeah, no, that's a great question. So, University of Minnesota, Graham Candler in particular, he is a national asset.
He's a big deal in the
Oh yeah,
space, right?
world renowned. His expertise is just incredible. And it's really cool to see. We got a lot of folks on our team that actually have been students of his over the years.
Interesting.
He and I have collaborated. My PhD is in hypersonics. We collaborated a long time ago when I was doing my thesis. So he has really built an incredible capability here for advanced modeling and simulation for hypersonics, in particular, aerodynamic flows and how materials respond to these environments. He has developed tools and codes that the industry uses to develop systems of this nature. Um, because of that, one of the things we've been working with him closely on is now how do we take the research he's doing at the university, which is done, in an academic setting, and we want to be able to enable him and his team to now have access to state of the art test facilities so that they're able to start moving beyond the campus facility and the restraints that they have just on again just computing power, access to tunnels, access to test data, and be able to move now into an environment where you can take his tools that they're developing and now apply them to real scenarios, real capabilities to again continue to help accelerate the learning in that environment. So it opens a whole new avenue for one industry's benefit of getting those tools into our hands faster, but then also gives him more access to data, more access to test capability to then further develop his tools and his research. So it's an amazing partnership because we both get a lot out of this relationship. And again, Graham's just been fantastic to work
Yeah,
with over the years. So it's a great partnership.
that's great. Um, I want to talk about rockets.
Mhm.
We had Bill Harper on an earlier episode, and he was talking about how in this area of hypersonic missiles we've
Mhm.
fallen behind,
Mhm.
especially the Chinese.
Right.
Just to put a time peg on this, we started bombing Iran several days ago,
Mhm.
so we're still very close to that. Just wanted to put that out there for when this episode comes out. Where do you see that industry going? And I mean, why does research around that stuff matter?
Mhm. Yeah, really one of the challenges we had, or we have, and this is in a lot of technical areas, but in particular in hypersonics, we're challenged in a couple areas. So, just because of our processes and the way we do business in the countries, especially from a federal funding standpoint, again, we have funding cycles, budget cycles, political activity, right? Just truth, right, the frankness is we've had CRs, continuing resolutions, for a long time.
So just short-term
um
planning,
that's right,
short-term funding,
exactly.
not really like decades-long projects we're working
That's
on.
right, and it's always been hypersonics has been an area we've been investing in for a long time, but it's been very cyclical. There'll be a push to do a lot, and then money dries up, and then there's another push, and so what happens is without a sustained investment, you have the fits and starts over the decades and years. Over the last probably 5 to 10 years, the U.S. has made an incredible push in this area, and so money is now flowing. People are working this area, but we're also now running into challenges just with again the throughput at test facilities. We don't have enough facilities that have the throughput to do all the testing we need. It takes months to potentially years to actually plan out these tests, to find windows where the tunnels aren't being used, and then on top of that, when you actually go to fly, very limited places you can actually go fly a hypersonic weapon. And a lot of it has to do with the speeds, right? If they're going that fast, in a few seconds, you travel a very long distance. And a lot of our test facilities, as well as the ranges that we use, the test ranges, they weren't designed for extremely long range, high speed systems. They were designed for more of our conventional systems. And so we've had limitations on the resources to really mature these capabilities. And that's been a big push for this investment, is to bring capability to bear so they aren't the limiting factors anymore, really enable us to move faster. In comparison, if you look at the Chinese model or even the Russian model, because they're state directed, they don't have the fits and starts necessarily, right? That are based on the politics. They don't deal with continuing resolutions, and they can be very deliberate about, hey, we're going to go do this and just move out. And it's not right or wrong, right? Our systems all have differences and benefits and challenges. But I think that's been one of their benefits, is they can actually just pick a direction and go, and it's really state driven. And I think that's why they've made so much progress in comparison. On top of that, right, just a little bit more about our moral and ethical values of how we do business, there's going to be challenges, right? We're very cautious. Safety is of utmost importance in everything we do. Whereas if you look at some of the other nations that do this work, a little less concerned about where they fly, where they test. Whereas we are very deliberate about ensuring safety is always first in our mind when we go out and move out on these things.
Got it.
Yeah.
Got it. So as I understand it, a big chunk of our stockpile are, for lack of a better term, missiles that shoot like pop flies, and what hypersonics are much more line drive like. Is
Hmm.
that
Hmm.
broadly speaking correct?
Yeah, that's fair. It depends. There's really kind of a different series of systems. When you think about, right, kind of the various levels, there's your traditional ballistic system. So that's more of your nuclear reentry vehicles, where basically very large booster launches it to space. Physics takes over, right? In space, it just coasts, does its trajectory, comes down, guidance at the end to impact your target. And then on the other hand, you have the more conventional systems like a traditional cruise missile, like a Tomahawk, and those will fly like an airplane. Just maneuver. They have an engine on them, and they fly at subsonic. We have a couple things that are going closer to supersonic, and they fly more traditionally like an aircraft. Hypersonics is a really unique area where, because of the physics and the flight conditions, you're really traveling in kind of a near space area. So you're not going ballistic and going as high and far as the reentry vehicles do,
Okay.
but you actually go to that, right, that kind of medium ground. You're not quite in space, but you're not quite all the way in the
Like
air.
how high are we
Um,
talking there?
so you're talking on the order of 100,000 feet
Okay.
or so,
Sounds
give or
pretty high,
take.
but I
It,
guess
it's pretty high. Shockingly, when you're traveling that fast, air is still a big deal. It's really thin, but the way to think about it is, as you get higher up, right, the air particles are further and further away. But if you're traveling really fast, it doesn't matter so much because you're impacting these air particles at such a high speed. It almost seems like you're in lower atmosphere because you're encountering air at a much higher rate than you normally would. And that's the big challenge: is how do you design systems that are operating right on that hairy edge of space to air? So there's the aerodynamic challenges, as you probably recall, right? Space vehicles, when they come back in, get really hot. It's basically because all that energy that's coming in gets dissipated in the shockwave as heat. Same thing you experience in these vehicles. So it's a really challenging problem to fly in that region. But the benefits of it is you have ability to do high cross range maneuvers. You can cover a lot of area. You can travel at very high speeds, and you actually kind of work along that curvature of the Earth, as opposed to these high long trajectories that go way out into space.
interesting.
Yeah,
Interesting. Sounds like a lot of math that is really, really far over my head, more than 100,000 feet.
pretty high.
So might be a bit of a simple question, but how do you shoot a missile in a wind tunnel or test a missile in a tunnel?
Yeah, no, that's it's good. It's so the it really the challenge you run into. So the physics itself, right?
Mhm.
When you're doing a flight test, or right, you're flying in the real atmosphere. The way to think about it is, in general, the air is not moving, but the vehicle is going very fast,
Yeah.
right? So really hard to do that on the ground. So instead, we kind of flip that problem around. Instead of the vehicle going really fast, we have the air go really fast. So you're essentially putting a model of the vehicle in the wind tunnel, and you're accelerating that air over the vehicle to mimic the same speed. So
Okay.
so it's kind of an inverse of the problem. The challenge you run into with that, and that's why these facilities are so large, and the energy requirements, and how we deal with the airflow and all, is when you have stationary air, but you're flying a vehicle really fast. You think about, you're compressing all that air as the vehicle flies, and what happens when you compress it, it starts getting really hot, right? The flip to that is, when you're in a tunnel, the way you accelerate the air is you actually expand it, which makes it, volume expansion, so the air cools down as it travels faster. which is the opposite of the problem we have when you're really flying. So what you have to do when you're in the tunnel is you have to add heat to the airstream. You have to energize it to best mimic and simulate what it would really be in the other area. So it's an invert. It's kind of a flip of the problem, and that's why we essentially heat the air as we accelerate it through the tunnel. So you come down through a nozzle, you expand it, and so it volume expansion accelerates the speed of the air, and it goes over the model, and that's where we take the aerodynamic data and things of that nature.
And very interesting. Um, so we're a week into a conflict in the Middle East.
Hmm.
By the time this comes out, who knows what that will look like?
Hmm.
These things tend to sort of change the way that people are viewing or thinking about an industry. Is there anything in the industry that has changed about the way that we are preparing or we're looking at the world that feels different than maybe a week ago?
Hmm. I wouldn't say a significant difference from a pure just fundamental step change, but I think what we're seeing now really bolsters the challenge that we've been trying to deal with for the recent past, in that for decades we've been in different conflicts and the need for different type of weapon systems, and what we're seeing is the overall industry has been very focused on more of a traditional model, back where you have the big primes and it's a very deliberate process, and we had the time to develop systems, field systems, get them out there. What we're seeing now is the pace of technology is happening so fast. You see it in Ukraine, right? There's different UAVs coming out every other day. The pace of technology and the access to technology is just incredible. And if we stick with the old models of taking these long, deliberate processes, right, a traditional acquisition program in the Defense Department could be anywhere between 8 and 12 years. The amount of technology developed while that one program evolves is mind blowing.
It's
So
just not built to evolve fast enough.
exactly. So I think what you're seeing with the Ukraine activities, with the Iran activities, is it just really emboldens the whole concept of we have to think about a different way to get capability and really accelerate our ability to get things into the field, and really pace it at the pace of technology and not the pace of the process that it takes to field something. And that's where, again, coming back to some of the early things we discussed, that's why it's so important to look at how do we bring these new technologies into our test environments. So again, I could go from a 6 month process to a 2.5 minute process. How do we accelerate our learning? How do we accelerate our ability to go from concept to prototyping? And when you look at what we're doing at the Minnesota Aerospace Complex, the real capability there is, yes, we have the tunnels, yes, we have test capability, but we're really bringing a AI driven digital ecosystem to the table that's helping our partners, helping some of the small new entrants into the defense ecosystem, as well as the prime integrators, learn faster. So they could, the dream, I always say, is, can I come up with a concept in the morning? Can I 3D print it at lunch? Can I test it in the afternoon, iterate the design overnight, print again in the morning, and test again the next day, right? That cycle would take months upon months. But with the technology we have today, I think it's within our grasp to able to actually get through these design phases in days to weeks versus month to years.
And you think that could happen in Minnesota?
Absolutely. No question. It's going to happen in Minnesota. What we're looking at and the partners that we're bringing on board to this, I think everybody is aligned to make this happen. And we're already demonstrating some of those AI tools, like I mentioned earlier. So I think that it's absolutely a viable path. And again, we've been reaching out because, a year and a half ago, Northwind wasn't doing a lot of digital engineering. But with the partnerships we're creating, especially around the defense ecosystem blowing up here in the state, getting great partnerships with AI technologies, and technology companies, working with other partners in kind of 3D printing and things of that nature. And so there's this, really kind of foundational growth in technologies up here in Minnesota and the upper Midwest, which frankly has been an untapped area for a long time. One of the things we're really interested in, if you look at kind of the history, the coastlines have gotten all the press over the
Yeah.
years, right? That's
And
where
all the funding.
that's right. That's where the labs are. That's where a lot of the test ranges are. That's where, a lot of the universities have, facilities where they're doing this research. And you look at the Midwest and in particular, right? You look at Minnesota, Wisconsin, Michigan, North Dakota, Indiana, just incredible capabilities there that have had, success over the years. But what we're seeing now is we're seeing this groundswell of partnerships occurring. And as the aerospace complex is coming to fruition, there's more and more partners that want to collaborate in this environment. And this is, the really exciting part for me. So don't get me wrong, I love the wind tunnels and the hypersonics
Hmm.
work. But the really exciting thing for me is we have these partners from all around the Midwest, and even some outside the Midwest that are hearing what we're doing, and we're getting phone calls of, hey, how do we get in on this? How do we have a footprint up there? How do we leverage these facilities? How do we leverage the digital environments you're creating? And so we're quickly moving into, yes, this is an aerospace complex, but it's quickly becoming a kernel of an innovation hub where folks want to be around this hub to really look at more of an advanced research and development center. And, we've been kind of joking around. We haven't known what to call it. So we're saying, hey, we're establishing the Great Lakes Research Center. But it's a really amazing opportunity to bring kind of the best of the best around the area and all collaborate to drive for national capability and the benefits of this country.
Wow. So what I've heard a lot about this sort of ecosystem that's
Mhm.
growing here in Minnesota, and it feels like it's rapidly accelerating and it's still kind of new. Tell me a little bit more about how this is coming together, and I mean, what are some possibilities of what this looks like in 10 years?
Yeah, that's the exciting part. I need to look up the exact data, but Minnesota is either 50th or 51st in the country in defense spending.
Yeah, it's crazy.
And it is mind-blowing because of the amazing technology and companies and capabilities up here are just they're phenomenal and they're untapped. And so there's been this defense ecosystem that has been created, started as a consortium of the willing that has really started gaining traction of how do we start connecting these innovative agile companies, a lot of the legacy companies that are here. There's a lot of phenomenal companies that have been here for decades that have capability that can be really brought to bear for national importance. How do we look at that and start connecting those folks to collaborate more, to work together more, to ultimately drive, capability and benefit to the nation through that defense ecosystem? The Department of Defense is the biggest funder of research and development in the country,
Right.
period. And a lot of that work that is done is dual use technology, right? Great examples are, Velcro was for the space program, right? And it's on my 4-year-old shoes,
Mhm.
right? It's on every pair of shoes that he's ever had to date. And you think about, some of these technologies that have spun out from this defense R&D work, and you just look at what we can harness here if we're able to leverage those sources of funds. And so I think it's a great opportunity for the state. I think it's huge for the nation. Again, I'm totally geeked out on, like, the national hypersonics facility is going to be here in Minnesota, which is
Yeah,
awesome to see.
it's really exciting.
Yeah.
We were talking a little bit right before we started about the actual construction of this thing, some of the local partners you guys have, and then just a general timeline. When can we see this, and how is it going to kind of come together?
Yeah. So yes, this morning I was actually over with BWBR. They're doing our overall architecture design, plant layout, everything, and we've just had just phenomenal relationships and support from the community. BWBR is on the team. Mortensen. We have Merrick doing some of our classified facility work, and it's just been such a great teamwork on that. Kimley Horn with the layout of the land, and then the collaboration with the county and the state. Rosemount has been awesome. Dakota County has been awesome. Like it's just This is such a I'm gonna go a little tangent here, but this is such a unique time in history, that one, just absolutely humbled and blessed to be part of it, because the bipartisanship, the local community engagement, like everybody is driving this to happen, right? There is not an individual I've run into that's just, how can I help? If you need anything, right? How do we do this faster? What can we do? And it's just been awesome to see. We had a big opening event back in January, and we had um, federal, you had congress people, senators, we had the local state government folks, we had the county folks, we had the buildings and trades representatives. Just the impact this can make to the Minnesota and the nation is incredible, because you think about the facility is about 60 acres, and you think about all of the technology that comes to bear in this. You have massive machinery, right? And we're talking things that are, you know 8-10 feet diameter compressors and tunnel components and nozzles, and just big steam pipes. And so it's an incredibly advanced technology, but it's a very industrial project. And so you
Right.
think about all the incredible building and trades folks we're going to need to build this out: electrical, water, power, steam fitters, all of those skills to build this facility. And then you start talking about, okay, then the operators of the tunnels and the STEM aspect of this. One of the things we talked about this morning with our partners is, we really want to have, as you come into this facility, an opportunity to actually go over to almost a little science museum of, this is aerospace engineering, this is how wind tunnels work, and open kind of a STEM part of this, because we want this to also be a workforce initiative, right? That this country uh, really needs start being more deliberate in some of these advanced technology areas, on how we start engaging students, all the way, at K through 12, and drive those capabilities, drive folks to that. So it's been such a cool opportunity to think more broadly about that. And so as we look at the bill, to answer the rest of your question, I kid you not, we got the paperwork done. We bought the land right before Thanksgiving. It was a beautiful fall. We signed the paperwork, and winter came the next day. We were so hopeful. We're like, man, with this weather we got, we can start breaking ground. We'll be working. Then the winter came.
We got a real one this year.
Yes, it was. So now the weather's starting to look beautiful. We actually think we're going to be starting to push dirt here in the next couple weeks, which
Nice.
is awesome. And we'll start building out. We'll start, most of it is, this first couple months is land remediation. So the site we're actually on used to be a World War II munitions facility. So there is so it is a polluted, at the surface layer. And so this area has been vacant land
Just been
since
sitting
World
there,
War II,
right?
just
Yeah.
completely sitting there. And so we're going in, we're going to remediate the land over the next few months. The nice thing is, it's surface treatment, so it's just removing some topsoil, so fairly quick. And then we'll be able to start getting the utilities out there this summer, start the buildings, and we'll have the first tunnel online in late 27 to early 28. And then the next tunnel will be about 2030 timeframe. And then the last tunnel, which is that advanced aero propulsion one I talked about, the hardest one of them all, that'll be about 2031. So here over the next couple of years, we're really going to be moving out, and the amount of activity that's going to happen is just going to be mind blowing.
Yeah. Fascinating. Um, when you guys were doing the deal with the university, there were protests from some students.
Mhm.
What do you say to people who are uncomfortable about this work happening, or opposed to it happening? And how do you make the case to them about why this is a good thing for the
Mhm.
state and the community?
Yeah. So first off, and want to be super clear, no weapons are going to be built at this site. We are an independent test organization, so we are going to be testing dual use technologies. Right. It'll be other folks' technologies, other folks' systems, and so we're going to be providing them test data. So again, no weapons development at the facility. It's really going to be all about that accelerated learning, right? Driving the STEM aspects of it, driving the accelerated learning, being able to contribute to a national need. And so for the protesters and the we've entertained a number of folks. We did some interviews in the fall, and really wanted to just walk folks through that. At the end of the day, the technology development, and again the dual use aspect, is just critical for the nation. There's so many other benefits to looking at these kind of technologies. I always, it's a fascinating story. It's a long way down the road, but I've even seen proposals of, this is again a random tangent. The amount of live transfer organs that get lost a year because of travel delays and can't get from point A to point B fast enough. I've even seen pitches from companies that are like, if we can do hypersonic space planes, we could actually save billions of dollars and be able to save lives because we can move things around the country much faster. And so I always go back to, yeah, we're not going to hide that this is funded by the Department of Defense, right? There's applications that they are looking at, from space access and other areas. But the dual use technology aspect and the learning that we could have as a country, is just incredible. And again, who doesn't want to get out of town in the middle of the winter and get to Honolulu in 45 minutes?
Yeah.
So again, it's really just the start of opening a whole new area of space research, aircraft research, and things of that nature.
Yeah. Interesting. So, thinking about that flight piece for a second, what are the actual technical constraints that are stopping me right now from being able to get to London in an hour or two?
Hmm.
Like, what are the hurdles that have to get overcome to make that a reality?
Yeah, yeah. The really the biggest challenges are, you're flying at these speeds where frankly everything wants to tear you apart. You're at incredible speed, so the temperatures get incredibly hot,
Like how hot?
thousands of degrees, right?
Wow.
Yeah, you'll melt. Metals will melt. Systems will burn up. And so you have to figure out how to deal with that thermal energy. There are lots of different ways to do it, but you have to create a vehicle that's going to fly in an environment that wants to just either burn you, melt all your components apart, or because of the aerodynamics, sometimes the G levels can be really high, and G's is basically the force on the vehicle when it maneuvers. And so you have a high G system. So basically, think about, right, when you see the guys in the space shuttle, right, when they're being launched, the human body generally can withstand, if I recall, it's 9 or 10 G's, right? Kind of 6 is, I think, where you start passing out and things like that. And some of these vehicles are 10, 15, 20 G's. And so you have to think about designing components that can handle that. When you talk about a manned flight, right, you have to really design to be able to accelerate through that profile. That goes back to that trisonic tunnel I talked about, is how do you go from low speed to then faster speed and then to hypersonic speed? How you do that in a profile that, would accommodate the human body, how you do that from a propulsion standpoint, because turbojet engines, like you see on a regular airplane, do not like flying when there's incredibly high amounts of heat coming into the front of it. They don't last very long. And so you have to be able to deal with, using those type of technologies to get you up to a certain speed. And then you need to transition to some of these high speed propulsion systems called ramjets or scramjets. And a good example is, if you recall, the SR-71, the spy plane, the
Mm-hmm.
long, black,
Yep.
really cool looking thing. That was ramjet powered. And I've actually knew some of the folks that have flown that, and they'll tell you stories of the windshield gets so hot when they're flying. They wear gloves and full spacesuits when they're in there because the windshield's getting hot. If one of the engine goes out, the amount of G's that get imparted on the vehicle, you can get hurt in those scenarios. So you really have to design for the overall system, and those are the things that we'll be testing in this facility. Is how do you develop the propulsion systems to be able to do that? Take off to landing. How do you develop the aerodynamics to be able to maneuver? How do you deal with the heat flows, things of that nature? And those are the challenges that we'll be tackling in this facility that would enable those future capabilities.
Interesting. So, 20 years from now, do you think we're there?
I do. I think we're there in certain areas. I think the manned hypersonic aircraft has a lot of work to go. You're probably talking We might be there in 20 years. I think the unmanned systems are there today. I think you'll absolutely see those. Just right, Russia and China are already demonstrating them. So we have capabilities, right? The country's got some prototypes out there. We have some limited capability. So I think in the next decade, you'll see many more in the unmanned area for this, and then probably in the 10 to 15 years, much more capability to get to manned aircraft in that.
Are you going to go on the first test flight?
Heck no. I don't do well on roller coasters as it is.
I don't like roller coasters either. They're scary.
They
They're
are.
scary.
They
a little
are.
spooky. So 20 years from now, you're looking back on your tenure at the company. What does Northwind look like in 20 years, and what do you want to have helped build?
Yeah, that's great. So, where I really think we're heading is go back to one of our sayings. It's all about learning faster. And yes, we're doing a lot of wind tunnel work today, but again, I go back to the reality is we're actually delivering and driving that AI ecosystem, the digital ecosystem. And when you think about the digital ecosystem, right, it's really kind of the kernel of everything we do. And the first instantiation is the aerospace complex with the hypersonic tunnels. But that same ecosystem now can support other test facilities. It can support other multi-domain operations. So one of the things that is really challenging to test is when you have all these different systems, right? A great example would be, I have an air platform that's communicating with a satellite that, is communicating with an unmanned vessel that's on the, sea surface, and you're trying to do, command and control between those systems. Our systems are so complex, it is really hard to test them in relevant environments. And so being able to do a lot of that in the digital environment is going to be huge for the country. And so what I see Northwind going is really being an enabler to bring a digital architecture to the table to help customers, everybody from government to the new starts to primes, think through that whole problem of a really complex integrated system and make sure that they can develop and deliver capabilities on accelerated timelines. And in the like I said, in the near term, it's very focused on the aerospace piece. But there's no reason why you can't start thinking about that in other domains, right? Ag engineering, bioengineering, because everything we're doing these days are getting more and more complex, and being able to do more in the digital environment is just going to enable our ability to do those things. So I see Northwind in 20 years as a major provider of digital architectures to help our customers accelerate learning, accelerate capability.
Really interesting.
Yeah, it's fun.
Yeah.
It's exciting.
Well, thank you so much for the time.
Absolutely.
Really
Thank you.
appreciate
This
it.
has been great.
Yeah.
Great. Thanks.
That's all the time we have for today. Thank you to Keely Doyle, Ali Alt, Connor O'Neill, Mike Novak, and Gabe Noah for all your work behind the scenes. We will see you next time.